Welcome everybody. Good morning, good afternoon, good evening. My name is Luc van Vught, as you might know, the moderator of today's webinar, in which or for which I've invited Stefano D'Emiliano. It's number 81. Yeah, we're progressing a lot. And yes, Stefano, of course, is the talker of today, creating high-performance, low-code workflows for Business Central, what's new in Azure Logic Apps. It's a presentation he also gave at Directions in Lyon, and I asked him to step in because I wasn't able to join in. That was let's say, a very egoistic trigger to do that, but I thought that would be surely many more people that would be interested to get your story, Stefano. So very welcome. I'll leave some more of the introduction on yourself to yourself. But before I'm going to hand over for you as presenter, I'm going through the standard slides, like the housekeeping rules. For everybody, you're invited to interfere in the sense of interact with questions. Put that in the question window of GoToWebinar. Your microphone is muted and stays muted, so I will be picking up your question and pose it to Stefano. We agreed that I will pick them up and post them at the end of the session. So we stack them and leave Stefano to tell his story in one run. So be invited to feed in your questions. And yes, we will have this recording also on our channel on YouTube, probably this evening already, and feel free to share it, reuse it. You're more than welcome, of course. I've been continuously working on new sessions. There will be a newsletter out somewhere in the next week or weeks, at least surely in February. If you want to be in the know and be getting the newsletter, use this URL to subscribe if you haven't done that yet. So what's ahead? In 2 weeks' time, we'll have David Singleton talking about, let's say, his journey or how he looks at our journey moving from Navision to Business Central from a more business perspective. On March 4, 2 weeks later, Kamil Sajek will do his solid principles presentation, a presentation he did last year at Days of Knowledge in Odense, and I wanted him to do this again because I think it's very meaningful to step in and learn together more about Solid. There is one ahead 2 weeks later on, well, it would be something on APIs with Arend-Jan Kaufman. The topic is not fully set yet. We're discussing on that, but I already reserved this slot for him. And then 4 weeks later, on April 15, because in between it's Pentecost, Monday, and that's not a normal thing here in Europe to plan something. A session by Patrick Schiefer on object-oriented approaches, also a directions presentation he did, and I liked his overview very much, so I asked him to step in. And then May 13, Microsoft Copilot and AI, a session by Niall McGovern. So there's quite a number of things ahead, and some things still need to be communicated to you guys. So, as always, my, let's say, urge to ask you, do you have topics? What do you want to become a speaker? Well, you're welcome to join in. That's it for the introduction. That leaves me to thanks for enough. Before I'm now going to hand over the floor to Stefano. So feel free to share your screen, Stefano. Open up your microphone.
Good afternoon, good evening, good morning to everyone of you joining this webcast. And thanks, Luc, for hosting me today.
More than welcome.
The webcast about today is creating high-performance low-code workflows for Business Central. I will do quite a lot the same about what I've done in the session in Directions EMEA, as said by Luc. So my goal for today is talking about why we are talking about low-code in Business Central. And then after that, just moving to a quick comparison about Power Automate. That is what I think is the most well-known low-code workflow engine for Business Central compared to Azure Logic Apps. That is what I want to put the focus today. And today I want to show new things about Azure Logic Apps. And to do that, I plan to give you an history, a real-world case, and how we solved that real-world case, the problem that we have, and how we solved this real-world case by using new features. Some of them are also in preview from the Logic Apps platform. And then, so give you some tips about how you can create high performances, low-code workflows for BC. So let's start in this path. As an introduction, why we are talking about low-code workflows? Because I think that when in many Business Central projects, integration is always one of the tasks that you need to perform. So it's quite common that in a real-world project, you have Business Central, and then you have third-party applications that you need to integrate, and also workflows that you need to have in place, for example, for putting data inside Business Central or integrating the external data. And these workflows sometimes are much better to be created outside, if you can, from Business Central, instead of doing long tons of code in IL language and, for example, job queue task to perform data import or something like that. There are a lot of tools in the Azure platform that can help you on that without writing lines of code, and also in a very powerful way. So low-code workflows help you automating tasks without writing codes. And so that permits you to reduce the cost of implementation because you have a lot of connectors available. You save resources because you don't have to create resources in order to deploy your infrastructure, but you can reuse something that someone else has implemented for you. And low-code workflows have also the power of to be self-explainable. So in a low-code workflow, you don't have a lot of lines of code, but you have a wiser way to see the workflow in a graphical way and put blocks according to the actions that you want to perform. And you can also easily readapt the workflow. If some rules changes in your flows, you can redesign and remove the actions according to your new rules, and the workflow can be redeployed and adapted to that rules very quickly. Low-code workflows have the power of connectors. So with low-code workflows, you have tons of available connectors that permits you to integrate with quite every application that you have, not only Microsoft related, but also third-party related. So you have connectors that spans the entire stack of Microsoft products, but also you have connectors that permits you to connect to applications that are not Microsoft related, and you can create your own connector. So if you have custom application, you can create your own connector. Connectors are shared between Power Automate and Logic Apps. So the same connectors that you have in Power Automate, if you are more confident with Power Automate, you have the same connector also in the Azure Logic Apps platform. The Azure Logic Apps platform has something more because it has also connector for enterprise application like SAP or something like that, or EBI, IBM application, mainframe application that you don't have in the Power Automate stack of connectors. But despite the connectors, that is not the topic today. What I want to put the evidence today is that first, writing a good workflows in low-code way is not just putting actions in the chain you want. So it's very easy to create a low-code workflow because you can design it as you want, putting actions, triggers, and then these actions, calls these actions, and so on. But sometimes being too easy also relies in a final product that works, but that sometimes is not optimized, especially in terms of performances. When evaluating a workflow, so an integration task, especially, you should be carefully evaluate that, and you should use the right technology for the task that you want to do. And especially remember that with low-code workflows, it's very easy to create a workflow. But if a low-code workflow works with a small set of records, it could probably fail when the set of records becomes very, very large. you should evaluate that, because sometimes low-code workflows cannot scale so much. And be low-code, so be easy, is different, and it's an anti-pattern in terms of performances. And this can be always be evaluated when you perform a low-code solution. In Business Central, normally we have two main platforms for creating low-code workflows: Power Automate and the Azure Logic Apps platform. Power Automate, I think, is what every Business Central developer and user, power user, knows as the de facto standard in low-code workflows for Business Central, because Business Central is natively integrated with Power Automate. You can call a Power Automate flow also from the user interface. Power Automate is absolutely a great choice for creating low-code workflows for Business Central. But I usually, when I talk about that, I usually say that Power Automate is the great and the solution for creating user-centric workflows. So if you have an actions that you want to automate that must be started from a user interface or something like that, or is strictly related to a user, Power Automate is the first choice probably to go. But it's different if you have, for example, an integration workflow that needs to perform an integration with an external system. This workflow must be run not in the context of a user, but must be run scheduled or something like that, or according to triggers, and needs to be performant. Power Automate, in this case, is a solution that is not the best choice. Power Automate is linked to the user that creates it. So a flow that creating Power Automate is linked to that user, and the owner of the workflow needs to share it to other users if you want to use that workflow. Otherwise, the workflow is linked to him. Power Automate runs in your Power Automate plan and in the context of Dataverse. So you cannot scale it. If performance are poor of this workflow, you cannot do nothing. Or you redesign it, or you cannot do nothing. You cannot scale, you cannot load balance it, you cannot create more instances of the flow in different regions, because it's linked to your Dataverse environment. Monitoring is limited, and Power Automate has new features launched in the last 2 months. At the direction EMEA, we show them new features about monitoring, but the monitoring is in any case limited compared to other platforms. Power Automate has the concept of connectors that are standard and premium. So if you want to use premium connectors, you need the Power Automate premium license. Remember that. You cannot use every premium connectors for free. The other low-code platform that you can use in Business Central for creating low-code workflow is Logic Apps. Logic Apps is something more, is something like the father of Power Automate, because Logic Apps is a superset of Power Automate. In Logic Apps is more enterprise level than Power Automate. Logic Apps is related to Azure, so the workflow is not linked to a Power Automate plan or a Dataverse subscription, but is linked to an Azure resource group, and you can deploy it where you want. So if I have a Business Central instance in Western Europe, and I want to deploy these workflows in Western Europe at first, and then, for example, also in East Europe, because I need to be reliable, you can do that. No, you cannot do that in Power Automate. You can load balance workflows in Logic Apps. Logic Apps have full integration with Azure Monitor and Application Insights. You can monitor every steps of the workflows. You can also put Logic Apps under SUS control in order to have workflows that you can move easily and automatically with pipelines between environments. Logic Apps supports more complex authentication mechanisms like managed identities, not for the BC connector at the moment, it's planned for the future. And especially supports lots of features related to performance that we'll see later in the section. Related to that, Logic Apps have different models. Power Automate have no models. You Power Automate, you go into makepowerautomate.com and you start creating your flow. In Logic Apps, there's the concept of what type of model of workflow you want to create. And Logic Apps have two main plans. The first is the consumption plan. The consumption plan is what is called the multi-tenant environment plan, because you pay per use, you pay per actions executions. Power Automate, Logic Apps doesn't have the concept of connectors, premium and standard, but you pay only, we can use every connector you want, and you pay for action execution, 0.00 for actions. In the consumption plan, you pay for actions, and you are runs in a multi-tenant environment. This means that under the hood, your workflows are deployed in an environment together with other workflows running. It's the same concept as Business Central. A single Logic Apps in the consumption plan can have only one workflow running. And this is the starting point, I think, when you start using Logic Apps, because it's the more cost-effective way of creating Logic Apps. If you want something more, and if you want something more powerful, you can go to the Logic Apps Standard way. The Logic Apps Standard way is a new model for Logic Apps. In this way, in this model, your flows runs in what is called a single tenant environment. So your workflow are not shared or no resources shared with others, but you pay for an hosting plan, CPU and memory, where you can host every workflow you want. Logic Apps Standard are a new concept of Logic Apps, the future way, where probably the platform in the long-term future will collide. Logic Apps Standard has a portable runtime, the same runtime that runs also Azure Functions, that can be run anywhere. And this means that Azure Logic Apps can also be containerized or can also be used on-premise in particular cases. Logic Apps Standard permits you to create two types of workflows. What is called stateful workflows and what are called stateless workflows. These are extremely important because according to the workflows type that the workflow that you want to create, you can go for stateful or stateless. Stateful normally is the standard workflow, low-code workflow that you can have in mind, exactly like in Power Automate, the same. So stateful means that these workflows save the states on every action under the hood in a storage. So when you execute these workflows, you have a set of actions. Every actions, when executed, saves the states under the hood into a storage. And this permits you to have full monitoring, full run details of the workflows, and resiliency and something like that, and having long-running workflows also. The other new type of workflow that you can create in Logic Apps is what is called the stateless workflows. And stateless workflows are particularly useful when you want to have very quick actions and you don't want to persist the state into the storage. So if you have calculations or, I don't know, something that for you is not important to save the state, but you want that is very quick in execution, stateless workflows are a great way to do, because stateless workflows runs entirely in memory without using the underlying storage that every low-code actions uses. When you create a low-code for workflows in Power Automate or in Logic Apps, you drag in actions into the designer, and these actions under the hood uses Azure storage for storing inputs and outputs, and also logs and something like that. Stateless don't do that, runs entirely in memory, but limit of state, the power of stateless is that are very, very quick, very, very fast. The drawback is that they can run only for a shorter time, less than 5 minutes. Otherwise, you have a high timeout. And if you have interruptions, the action fails, and you can restart from that. But these are two types of workflows that permits you to create very powerful flows today with Logic Apps Standard, and that are not present in Power Automate or in Logic Apps consumptions. Stateless are synchronous, while stateful can also run asynchronously. So just to very quick show that, I open my my Logic Apps environment, and the first thing that I want to quickly show is that when I create a Logic Apps now in the Azure portal, if I click on Add New Logic Apps, you can select a resource group, obviously, as every Azure resource. Now I select a random resource group from my existing, and after giving the workflow name, you can specify the type of workflows that you want to run. First, the region. You can select an Azure region, so where your workflow must be run. You can exactly select the Azure region that you want to be or also be available. This is not possible in Power Automate, for example, because Power Automate are always creating your dataset region, Dataverse region. And remember that the Dataverse region is not exactly the same region where you have Business Central. Often. So sometimes this affect can affect performances. I've blogged in the past how you can specify a Dataverse environment creation in exactly your region in that you have where you have Business Center, and this can be done via PowerShell. But when you create a Logic Apps, you can also specify the plan consumption. This is the old way, and now they're also the standard. The standard. If you select standard, it asks you for what type of standard pricing plan you want to select. And here you can specify one of the available pricing plan. Obviously, the standard plan gives you a lot of power, gives you a lot of performances, but you have to pay a fixed price. So you don't pay for workflows executions, nothing. You can deploy every workflow you have in it, but you pay a fixed price accordingly to that plan you select. And then you click create, and you can start creating Logic Apps Standard. Now I don't do that. When you have a Logic Apps Standard, I open one of my available Logic Apps Standard, for example, this. You can see from here a first difference compared to the standard way of Logic Apps. Of creating logic workflow with Logic Apps. The first difference is that now you have a workflows tab. Workflows tab, why? Because in Logic Apps Standard, you can have more than one workflows inside the same Logic App. Things that are not possible with Logic Apps consumption. You have only one workflows in a Logic Apps consumption app. And also in Power Automate, only one workflows. Here you can have more than one workflows inside the same app. For example, in this app, I have 6 workflows running on the same Logic Apps. And here I want to show something, the first useful new features that you have in Logic Apps Standard. One, for example, is this. Here I have a workflow that fails. And imagine that I don't know why it fails. Or I can go into the designer. This is a workflow that does some things, starts from an HTTP request, does some things, and in a certain point calls an API with a particular URL. If I select my workflows and I deploy my workflow and imagine that a day this workflow fails. I don't know why it fails. I click and I can see that this workflow fails in the HTTP call. Why? Simply because this is not a valid URL for this API. What you can do in, imagine that the actions that you have done before has done a lot of work. So parsing files, import the data from an external system and something like that. And maybe it can take, I don't know, 1 hour of work to arrive here. And the API calls fails. Here I can simply, change this URL, fixing this URL, and then I can click submit from this action. And this is a new feature available in Logic Apps that permits you to restart that workflow from this action and not re-executing all the available actions that we have done before. So for example, if you have imported data before, you can start from here. And this is quite useful if you have this type of workflows. Another new feature that I want to show you in Azure Logic Apps Standard is the possibility to decouple workflows. And this is a very powerful feature that I recommend to use if you have complex workflows. in this example, for example, I have a main workflow that performs some things. Come on. For example, starts with an HTTP request, retrieves customers from Business Central, and then for each customer calls another workflows in this workflow app. So this is a new action available in Azure Logic Apps Standard that permits you to invoke a workflow in this workflow app by passing parameters. So in this case, I'm calling these workflows, and here you can select all the workflows that you have inside this app. In my case, I call it child workflow. I pass this parameter. It's a JSON set of parameters that you can pass. And the other workflows is simply another workflow. It's this that in the designer retrieves the parameters and does actions. So here, for example, after retrieving the customer from Business Central, I pass a parameter of the customer to another workflows, child workflows, that performs some checks. In this case, it checks the condition to the customer balance due date, and if a check that's register things in an external system, otherwise not. And this is, instead of doing that in a single workflows, I can decouple things and do that in a child workflows that permits you to have more performance gains. And these child workflows could be also stateless. For example, if I don't need to persist the state in memory or something, to persist the state in storage or something like that. Another powerful features that you can do in Logic Apps Standard according to that is something like this. So here I redesigned the same workflows. These workflows retrieves items from Business Central, using the Business Central connector. And for each item retrieved, I want to perform some operations. In the previous workflow, you have seen that I have a loop, a for each loop, because for each item, I need to call the child workflows. In Logic Apps, you can do also a trick that permits you to gain performance in this case. So here, as you can see here, I don't have a for each like before for calling calling the child workflows inside the for each block. But here the workflow is linear. I'm simply passing the parameters to my invoke a workflow in this workflow action. So I'm calling these workflows, passing the body of this find items action. In the child workflows, here, if I go into the designer, I have used a trick that you can use in Logic Apps. So this child workflows receives the array of items that I have extracted from Business Central, and Logic Apps can permit you to go into the code view. And in the code view, I've used this trick that is a new keyword that you can use when you have an array of parameters to split the execution by a key in the JSON that you have. In my case, data is the data that contains each item coming from Business Central. And this permits you to split the execution of the Logic Apps to different threads accordingly to the data you have. What happens if I execute that? If I run the main workflows, so if I go here, I click on run, what happens is that the workflow starts and it retrieves the item from Business Central. It passes the items from Business Central, that are different items from Business Central, to the child, and the child is split in parallel tasks, each task processing one item. And this permits you to avoid a loop. And so now it's finished. And here I have one execution of the main workflows. And if I go into the child, sorry, too much. The child is here. I click wrong. Come on. I click the wrong button. The child is here. So if I click on, I select the child workflow, you can see that the child workflow is splitted. split on child. Okay, this is my child workflows. And you can see, as you can see here, I have different execution of the child, each one for each item in parallel. So if I go inspecting this, you can see that this is this item. And if I go inspecting another execution, you can see that the other execution processes different items and so on. So I processed, I don't know how items I have in this Business Central environment, I think 30 items or something like that. I process them in parallel. So all these execution in this date, you can see from here are quite a lot. I don't know how much these are, but quite a lot, are processed in parallel and not in a for each block. And this permits you to gain performances if you have a workflow that need to process data in parallel. These are some of the features that we have in Logic Apps Standard. But now I want to show you a more advanced way and a more real-world case that we have. This is a real project that we have for a customer. And this customer is a big customer that imports, work with vendors like Amazon and something like that. And they need to import every day a set of data files. And these data files comes from different sources. Some are uploaded into the blob storage, some are on SQL, comes from an on-premise SQL, and some comes from an on-premise Oracle database. These are all in JSON. These data files might be processed and must be merged. So what we need to do is take this data file, that is the source data file, and merge records between these two to see if they match. And the output of that, this complex operation, is a set of documents that are ready to be posted inside Business Central. And then I need to call APIs in Business Central to register or not the documents. When we start this project, in a traditional way. So this project was started by the internal IT of the company. We trained the internal IT of the company using Power Automate, and they started using Power Automate. When using Power Automate, creating the flows, they first start having some performance problem, and especially they start having reliability problems, because sometimes, as said before, Power Automate is linked to the database environment. So if you have the database environment available, your flows goes, but if others are doing operation in the database environment, and the database environment is also common to Power Apps, is also common to dynamic specified applications. In this case, they have, for example, dynamic specified for sales, and someone, when register plugins or something like that, creates blocks on the database environment. So they decided to move the workflows to a Logic Apps consumption way. And this can be done easily from Power Automate to consumption. And this workflow was creating something like this. So this workflow has a set of parse JSON operation, and parse JSON is the actions that you can use in Power Automate or in Logic Apps to parse an incoming JSON. After parsing the JSON in the incoming JSON according to a schema, to make the comparison between the different data files, you are forced to create for each blocks. So what this workflow is doing, for each, coming again for each, coming again for each, and so on, and make a comparison. And then for each accepted invoice, you can post the invoice in Business Central, and for each rejected, the same. This workflow appears slow, especially in two main parts. The first part where we experience slowness is the parse JSON, because parse JSON in Power Automate or Logic Apps is an action that sometimes could have performance problem if JSON is big. But the main performance problem here is this block, because this block uses for each. And for each is not only a graphical operations, but for each under the hood uses the storage and writes a data into the Azure storage under the hood, and this creates performance problems. This is our measure that we have done in this workflow, because we start, as said before, the company started from Power Automate, then moves the workflow to Logic Apps consumption, and Logic Apps consumption performs a bit better than Power Automate, but not so bit better. So I think that it's quite the same as Power Automate, except sometimes during the day where we have the spikes in Dataverse, that Logic Apps doesn't suffer of that. As a third step of trying to improve the performances of this flow, we move these flows to Logic Apps Standard. Logic Apps Standard performs better than the two previously C platform, because Logic Apps Standard runs in a dedicated environment with a set of powerful resources that you can specify. It's more stable. So we have an increase of performances, but as you can see from here, it's not so big. And in the table that I listed in the slides, you can see the time of processing one data file. And processing that way, one data file moves from for example, 3 minutes and a half to 2 minutes and a half. So we gain 1 minute, or less than 1 minute in medium. And this was okay, well, absolutely okay, when the customer has a small number of data files. But after about 6 months of working with this customer start growing. The number of data files that must be processed start growing, and we move from processing about 30 data files per month to processing more than 100 of data files per month. And as you can see from this table, if I multiply this time for 100 of files or 200 or 300 of files, this means hours. And these workflows, when the customer starts working a lot with Amazon and something like that, from 1 hour moves to 6 hours, 7 hours, because data files grows a lot. So we need to improve the performance of the workflows because it was not acceptable that 6 or 7 hours to perform that files for us was not an acceptable time. So we need to think of a way to improve the performances of these flows. The general rules that apply here is that when you have a nested for each loops is a performance problem in a low-code workflows, Power Automate or Logic Apps, because the scope of the action is persistent in storage on each iteration. So if you can avoid to have heavy for each loops is better. For each is slow, and also the part JSON is low. But the main problem is part JSON can be acceptable, but the for each was our main problem, because it was basically we need to do nested for each, forced to do that, and with nested for each we have problems on performances, and sometimes also for each loop you need to remember that if you have a variable assignment inside the for each loop could also lead into concurrency issues, because multiple parallel threads can try to update your variable in the storage, and then you could have problems. So we would like to try to avoid that. And to avoid that, we start using a feature that in Azure Logic Apps Standard is actually in public preview. We also, sorry, before saying that, we also try to batch to another Logic Apps, as you can see. I just see here, so create a child workflows, but we will not have a good gain on performances. So we try to use a new actions that you have, a new feature that you have in stateless Logic Apps, in standard Logic Apps, that is something like a mix between no code and code. and it's a new feature available actually in preview only in Azure Logic Apps Standard. But with this new feature that I later will explain, we have these results. So the same workflows moves from, I don't know, about 3 minutes of execution for processing a data file to some seconds to processing a data file. And here is the chart that shows that. So we was able to move the workflow from running in 7-8 hours to running in less than 1 hour for processing the same amount, big amount of data files. And the new solution is something like that. So it's a more linear workflows that here does something magic. So calls a function inside this logic app. And this was the killer feature that permits us to gain performances inside these workflows. And how this is done. To show you how this is done, I open Visual Studio Code because in this case we use Visual Studio Code. And Visual Studio Code permits you to work with Azure Logic Apps, consumption and standard. You need to install some extensions. In this case, we use the Azure Logic Apps Standard extension that you can use from Visual Studio, from the marketplace. You can install it from the marketplace. And when you have this installed, you can create a, let me close this, create a new Logic Apps from here, from Visual Studio Code. So I create a new Logic Apps workspace from here. It asks me for a local folder where to save the folder, and let me create here a new folder called Europa Demo. I select this folder. I need workspace. You need to select a name for your workspace, a name for your function app, and a namespace. And then it asks you what type of workflow you want to create, stateful or stateless. I select stateful. Stateless is the workflow that runs in memory. It's not the case. And here, give the workflow your workflow a name. So Europa Flow, for example, is the name of my workflows. And I open it in the current window. And it starts creating a project. This project is a particular project. Let me close this because I have already opened, so this service is not starts. Okay. This is a particular project. As you can see from here, this workflow has this project has two main parts. The first is a Logic App folder, and the other is a function folder. So in the Logic Apps folder, you have is where you can design your workflows as in the Azure portal graphically, but you can do that in Visual Studio Code. Simple right-clicking from here and opening the designer. And you can design your workflow by calling connectors, as said before, as you are usually to do also in the Azure portal. But here there's something more. Here there's this function folder. And in this function folders, there's a block of code that the standard codes, here is the standard template. And the standard template is proposing you a piece of code that is quite familiar if you count from Azure Functions. And this piece of code is simply a function, an action that has two parameters, a zip code and the temperature, and returns the temperature of a city. So it creates a random temperature between a set of scale of temperature that you pass in input, and returns this temperature as a JSON object with this format. So with zip code, current weather, day low, day high. It's just like an Azure function. So here I can, if I want to use this code, I can open a terminal into the function folder, and I can, if I list, I have a project, and I can build my project. So .NET build Europa function dot. I build my project. What happens when I build my project? It compiles all the reference that I have in this code, and it when the code is compiled, it creates a folder here called choose folders. One is artifacts and one is lib. Lib is where you have your flow definition, and all inside this folder you have all the assemblies that your function uses. You can use every assembly you want. And I can open the designer, and as you can see here, my flows can call a function with the parameters that I have specified in the code. And then this executed the logic that I have inside the code and gives you the response. This was exactly what we have done in the real world case. So I open now the project in my real world project. And what we have done, sorry, this is the wrong Visual Studio Code instance, right, is this. What we have done in this flow, we have simply created a function that these flows, if I open the first the designer, what this flows does, it reads some data files from the blob storage, and these are the data files that are imported from the external system. And then to parse these data files, I don't use parse JSON, and I don't use for each, but I simply create a function inside these logic apps that receive in input these two data files and performs the data comparison. When I have the data comparison, I do all what I want, as always in low code, inside my flows. And my function here is a simple function that I call it data parser. This simple function retrieves two strings that are the JSON reading from the blob storage, from the two files, two big JSON files that I need to compare. And the logic of comparison is done in code with some lines of code, because here I can use JSON convert from Newtonsoft, and JSON convert is a powerful JSON serializer, much more powerful than the parse JSON that you have in low code. So here I can parse the JSON very quickly. And when I parse the JSON, I have a list of objects that I can compare in code. So here is the comparison logic that I have in code, where I have the nested for. As you can see, I have a for each here, and for each items, I loops to another data item, comparing fields in this data item in order to detect if the invoice is rejected or not. If the comparison is okay, I create two arrays of accepted invoices and rejected invoices that are the output of my function. And what happens if I deploy this in the Azure portal? Here is the real world case of the Azure function running in standard way. So if this is the workflow as you can do in Power Automate or as you can do in Logic Apps. As you can see, I already the blob files from the blob storage, and then I parse the JSON from these two blob files, and then here I start some loopings. So here there's a for each loop that calls another for each loop in order to match the lines, and so on. So, and then when I have the array of for accepted invoices, I can call Business Central for each accepted, and for each rejected, I can call Business Central. So the core is these nested loops. If I run these flows, I run this execution, and I leave it running, you can see that probably it takes about this time to parse these data files, about between 3 and 4 minutes. Now I don't remember what data files I have loaded, but I think that it requires about 3 or 4 minutes. We'll see that later. What's the new version? The new version is, as you can see in code, is these flows. And these flows, if I go into the designer, does exactly that. So it reads the same data files from the blob storage, but now it calls a function in this logic app. And here is where it calls the function called data parser that I have deployed in my Visual Studio Code with the logic of only the logic with comparison. And when the logic of comparison is done, it receives in input the data files from these two actions. And then here I have my response containing the outputs of these actions. And from here, I have the accepted invoice and rejected invoice arrays that I can save in Business Central. And if I execute this action, run, you will see that now this action takes seconds to process the same data files. So it takes it's very fast compared to the action that I have here, that we check if it's finished or not. Not yet. That takes a lot of minutes. And this permits us to gain in stable performances and reliability, because I know that doing that, like in this designer, is very easy also for a no developer perspective, because you simply here drag and drops, and the for each is added when you loop, when you drag arrays. But this takes time. This is an anti-performance pattern where you have different nested loops. And moving that by using this new feature that permits you to embed a bit of code into an action permits you to gain performances. I want also to put in evidence that this can also be done calling an external Azure function, because from Logic Apps you can call Azure functions, but this is much more powerful because it runs in the same function app, and you need to maintain a same code base, because Logic Apps, as I said at the beginning of the webcast, permits you to save that into Azure DevOps or GitHub or something like that, and permits you to handle source control. So every time I modify something in my workflows, it's committed to my source control system and then deployed on Azure automatically. This is much more reliable. And this permits us to save the project and gain a lot of performances. Now, I don't know many files I have here, but trust me that comparison is from a lot of minutes to seconds. Another plus of the Azure Logic Apps is the possibility to handle reliability. And sometimes in many projects when you need to be reliable, this is a must. One of the limitations that you have in Power Automate and in the Azure Logic Apps consumption, mainly in Power Automate, is related to reliability. If you want to have an integration task that guarantees business continuity in case of a tenant failure or something like that, Power Automate is absolutely not the way to go, because it's linked one-to-one to the database environment. So if your environment is down, or in maintenance or something like that, restarted, I don't know, your flow is down. With Logic Apps, you can deploy the same Logic Apps template into different Azure regions. you can have a primary location and you can have a secondary location, and you can have a workflow that runs in different Azure regions accordingly to the customer that you have. And also you can load balance that. So Logic Apps can also be load balanced, and this permits you to have a workflow that can be split according to the data that you have in input to different Azure Logic Apps instances. Can process the file accordingly to the load. So you can have these two plus that you don't have in Power Automate. The first is business continuity, because you can deploy your workflow in multiple instances, and if an instance is down, another is up. And also you can load balance data across requests, across instances of flows. So generally speaking, to conclude this overview of what's new in the Azure Logic Apps platform, these are the main investment in the last months of the Azure Logic Apps team. The possibility to write Logic Apps blocks in code was one of the requests that I think we have done from a year to go to the Azure Logic Apps team. At the moment, the feature is in public preview, so you can start to use that in your projects. It works very, very good. So I personally use this feature in production in different projects. It gives you a lot of power if you have performance problems. So what the message that I want to pass here, despite showing these new features, are that low code is absolutely cool. I agree that it's should be probably the first step in order to create integration with Business Central, because it's easy to maintain and to create. But remember that low code is not always matches with performances. So if someone say you that with low code you can do everything, it's not always true, because you can do everything, but this everything probably is not always matches with performance, and this everything in some cases it's okay, in other cases it's not okay. The case that I showed a few minutes ago show that. So we have a low code workflows at the beginning that works perfectly, gives a perfect result, but it takes 8 hours to process all the files that the company have. By moving with a mix of low code and code, we have a tremendous boost in terms of performances. Workflows, low code workflows normally should be architected according to your scaling needs. So you need to remember and evaluate what type of performances you need to have in this low code workflow and architecture it accordingly. Remember also that when in low code, when you have, it's an anti-pattern to have too complex workflows, because what for you is simply an action that you drag in a graphical designer, under the hood there's a lot. Under the hood there's storage, different Azure storages, queue, that where messages input and output are passed, and so on. So having too complex workflows is anti-pattern in terms of for performances, and you should evaluate that. So sometimes it's better to split the workflows in more workflows, or use some code features where you need to maximize the performances. Generally speaking, Logic Apps outperform Power Automate for integrations. And I say that from a long time. I usually don't use Power Automate for integration tasks. I use Power Automate when the workflows is strictly linked to the user. So for automating actions linked to the users, for doing actions from Business Central, it's okay. But when you have silent integrations that need to be performed, like in this case, I have a big process that need to import data from external system and do some data processing and then save the data in Business Central. This is something that for me, Power Automate is not in case, because using Logic Apps is much better and much more reliable than using Power Automate. And last, I know that low code is easy. I know that low code is easy to do, nice to see, and so on. It's also a trendy in this moment. But if you want the best performances, and if you have scenarios where you need maximize the performances, sometimes mixing these two approaches is absolutely better. And Logic Apps platform now has this feature that permits you to embed low code and code. And last, remember the Logic Apps Standard platform permits you to also run Logic Apps on premise or on Docker. Obviously, you are limited to the number of connectors, but if you have scenarios where you need to run Logic Apps for a particular workflow inside your network infrastructure without going on Azure, you can do that with Logic Apps Standard, because Logic Apps Standard now runs in all the platforms supported by the Azure Functional Runtime. And this means Docker, and this means on-premise environments. Obviously, if you then use connectors that are available only online, these connectors might be taken from online, like, for example, the Business Central connector. But Logic Apps Standard can also be hosted on containers and on-premise. This ends what I need to say about this topic. I hope to have passed the message. My message was to show what's new, some things that are new here, and also to pass the message that low-code workflows are a great way to create integrations, but Logic Apps is the much more powerful and enterprise level than standard Power Automate. Costs are absolutely something to evaluate, I agree, because Power Automate, you pay a fixed price per user, while in Logic Apps, you pay in the consumption plan, you pay per actions. So quite often, a Logic Apps workflow is much more cheaper than the Power Automate. Obviously, if you go into the Logic Apps Standard platform, because you need to have enterprise level workflows, here you pay a fixed price, and you can run every workflow you have, but the price is fixed, so it's not for execution. So this ends my presentation. If you have questions, I'm available to answer. Otherwise, feel free to also reach Luke or someone of the staff after the webcast.
Questions can always be entered at underneath the YouTube recording, of course. Thanks, Stefano. There are actually no questions, so your story was loud and clear. There was one note from David Singleton. It looked like we have some full circle back to where just about anyone can develop solutions quickly, as we could in the Navision times, you could say, more or less. So back to the days of Navision, but at least it looks like plenty of performance tuning work for decades to come. Yeah, that's, of course, that everything is circling somehow. It looks like what I take from your story also that, of course, Logic Apps is the way to go performance-wise compared to Power Automate, and the visual side is a kind of proof of concept, and when it's working, but performance is in danger, you could say, then dive into using the local functions, I guess.
Yes, Logic Apps gives absolutely all the features that you have in Power Automate. So if you are able to create workflows in Power Automate, you are able to create workflows in Logic Apps, because the platform is absolutely the same, but the backend is not the same. So Logic Apps is the father of Power Automate, because Power Automate relies on all the Logic Apps stack. Okay. Logic Apps gives you more features in terms of especially performance. It gives you some connector, more enterprise level connectors. So for example, if you have scenarios where you need to integrate with IBM mainframes, SAP or stuff like that, you have connectors that you don't have in Power Automate, but this is not what I want to show today. What I want to show today and what I show today is mainly related to performances. Power Automate sometimes lacks on performances, especially on integration tasks. And Power Automate, it's okay if you have to import, I don't know, 3-4 files every day and parse these files. It's okay if each file you can take 5 minutes for processing data files, like one of the big data files that I have in these scenarios. But it's not okay if you need to import 1,000 of data files, because 5 minutes for 1,000 means hours. And if you need to do that, you need to do something more powerful. And Logic Apps gives you the power to create much more powerful workflows, also always using the low-code pattern. Logic Apps also is also as platform much more stable than Power Automate. Power Automate has the limit station that is linked to Dataverse, and Dataverse is not a database; it's a metadata plus database, and so in terms of performances, cannot be the same as Azure. So if the scenario is creating integration tasks using low code, because you prefer to go for the low code approach, in my opinion, Logic Apps is the way to go for silent tasks. Obviously, it's different if you need to create an action that from a user's sales order send a sales order to an external system. This can be done also in Power Automate, it's okay. But if you have silent processes that need to perform a lot of data, from on-premise data, from cloud data, and data manipulation, and then do operation in Business Central or in other systems, Logic Apps is much better.
Clear. One question came up from AJ Kaufman. Do approvals work the same in Logic Apps as they do in Power Automate, like visible in Teams?
Yes, approvals. You can do approvals. Also, you have the action for approvals also in Logic Apps. So you can create an approval workflow for Business Central also in Logic Apps. Yes. The only limitation of Logic Apps is that cannot be directly visible as an action in the Business Central client. So if you want to create an approval workflow, you need to probably trigger it with a custom action. Power Automate can be directly surfaced into the user interface if you create a workflow linked to an entity. With Power Automate, Logic Apps cannot do that because it's not tightly integrated. So you need to create, for example, an HTTP trigger and then call it from an action.
Okay, thank you very much.
Approvals, I think that approvals is a scenario where I recommend Power Automate normally, because it's an action. For me, it's an action linked to a user, an approval. It's a user that launch an approval for an order and so on. It's probably a type of flow where I don't recommend using Logic Apps. Possible, but probably not needed. Different is instead an integration task where you need to perform a lot of data and you need performances.
All right, thank you. We stole some more time of everybody. No questions anymore. So I guess, well, I need to thank you, Stefano. It was loud and clear, and hope everybody can draw the same conclusion as I do. So thank you very much. Thank you for everybody for attending. And hope to see you in 2 weeks' time when David Singleton has his webinar. So see you around at that time. Thank you.
Thank you, everybody. Bye-bye.